As the study of matter, chemistry deals with all the elements and their interactions. Now, in order to understand these interactions, first we have to know about the elements themselves, like what exactly they are, what they do, and how they would possibly react to one another. Since this is so much information, if we didn't have a way to organize it, it'd be nearly impossible to work any chemistry problem. Because of this, the periodic table itself was developed. The periodic table is a significant tool that helps chemists everywhere organize and remember specific chemical facts. Now, as chemistry students, we've had to familiarize ourselves with the periodic table on a regular basis. This understanding that we've developed has helped us solve many chemistry problems and learn chemistry itself. And without that basic understanding, it'd be nearly impossible to do these problems because it'd be like speaking a foreign language. How would you understand something that you didn't know? In this video, we're going to talk about the elements, how to read them, what symbols mean, and their organization. Why are they in the places where they are on the table itself?
Now we will talk about how to read and understand on the characteristics of the elements in the periodic table. For example, we will talk about carbon. The letter C here is the symbol of the elements or the name of the elements. And the next thing is atomic number. Atomic numbers is the number of protons of the nucleus in an atomic, which identical to the charge number of the nucleus. Last but not least, atomic weight is the mass of the proton and neutron. And for carbon, the atomic number is 12.011.
This is one of the most basic periodic tables we have today. The first thing we're going to start learning today will be periods and groups. Periods start from left all the way to right, and groups start from top to bottom. Now we have a total number of 8 groups in the periodic table. We're going to start naming them as follows. The first group is called the alkaline metals. The second group, which is from beryllium all the way to radium, is called the alkaline earth metals. Now from this row of scandium all the way to zinc, those metals are called the transition metals. From boron, carbon, nitrogen, and oxygen, they have a special name. They are named by the first element in that row. So this will be the boron family, this will be the carbon family, the nitrogen family, and the oxygen family. Once we get to fluorine, they have a special name for that whole family, which is called the halogen family. When we get to helium, the name of that whole column is called the noble gases. The next thing we'll start learning today will be our charges for each one of those families. The first family, which is the alkaline metals, they have a +1 charge. The alkaline earth metals, which is from beryllium all the way to radium, they have a +2 charge. Now when we start looking at transition metals, those elements have a charge that varies within each element. So it could be a +2 charge or a +3 charge, depending on each and one of the elements. When we get to boron, they have a +3 charge. When we get to the carbon family, they have a +4 charge. Now once we get to the nitrogen, that's when it changes. It changes to a -3 charge. Now oxygen will have a -2 charge, and fluorine will have a -1 charge. Once we get to the noble gases, they have a 0 charge, and that's because of the fact that they are stable gases, and that's why they have a 0 charge. The last thing we'll learn will be the lanthanide series and the actinide series. Now you can see those elements are at the bottom of the periodic table, and they are also known as radioactive elements. As you can know, as one of the most famous elements is called uranium, which we have heard in a lot of the movies and on our everyday lives.
So on the periodic table we have 3 types of elements. We have metals, nonmetals, and metalloids. And they're divided between the staircase ladder line on the periodic table. So everything towards the left is considered a metal, as everything on the right is considered a nonmetal. Now the elements that are touching within the staircase line are considered metalloids, because they can both contain both characteristics of metals and nonmetals.